Hi, this presentation is in fulfillment of the first assignment for the information retrieval module. This presentation will be an evaluation into two research papers. Paper 1 addressing the issues with the BM25 algorithm, and paper 2 is a discussion into latent semantic indexing. So I'm just going to start by introducing the members of Group 15 from left to right. It's me, Amir Mohammed, on the left-hand side, and the rest of my colleagues are shown on the slide. The structure for this presentation will be as follows. We have focused on two papers, which will be referenced later. Me and Henrique will start by discussing the problem addressed by the first research paper, followed by the proposed solution and the corresponding results. Thereafter, Nia and Aris will do the same for the second paper. At the end of the presentation, we will all collectively present our personal views on the paper. I will start by discussing the problem addressed under paper 1. For this, it is necessary to explain what the BM25 algorithm is as a crucial prerequisite. It is an algorithm commonly used in the past by some search engines that estimates the relevancy of a document. The equations related to this are shown on the right-hand side of the slide. The log function represents the inverse document frequency, which is dependent on the importance of a word within a query, and the term frequency and the length of the document is also accounted for. The whole algorithm is independent of the proximity of the term in the document, and it is great for unstructured documents. However, this does not take into account where the word appears within the document. So field score combinations try to solve this by treating each field, such as the title and body, independently and taking a linear combination of the scores. But this fails as most modern weighting functions are nonlinear. An example of this is shown and demonstrated on the graph on the right. Another practical example I can give is if you had a document with one word appearing once in every single field/section, it would score higher than a document where the query appears on every section except for a few multiple fields. This may not be relevant for a query in question, and the issue is also demonstrated on the right-hand side on the graph where the score comb is rated higher, despite the fact it may be less relevant to the query at hand. So how did paper 1 address this issue? The requirements of the solution were as follows. The simple interpretation towards the collection statistics and the length of the document were to be kept. The paper looked to preserve the nonlinearity and the term frequency, and the paper also looked to use the facts of reverting fields into an unstructured case. The proposed solution is as follows. By using the addition of a weight vector, we could take the sum of term frequencies from different fields through the formation of dot products with the corresponding fields. Therefore, what we could do is score the documents using the resulting term frequencies. As can be seen by the equations on the slides, the parameter d was adjusted by using this new weighted vector. And in summary, the current standard approach of weighting fields of a document using a linear combination of scores is problematic. Therefore, the paper looked to take a linear combination of term frequencies prior to the weighting, and this should overcome many issues.
Thank you, Amir. For the testing of the BM25 algorithm, it is used the web track crawl of the .gov domain, which is referred to as simply.gov in this paper, and the Reuters Volume 1 collection. These two collections reveal mainly just two sorts of text fields, title and body text. As an optimization strategy, they simply assess a system's performance on a smaller grid over the set of parameters being improved until a sufficient minimum step value is attained. For both term frequency combinations and score combinations, field weights are optimized in the same way, and both approaches have the same optimization cost. In the instance of term frequency combinations, it is observable that the weights correspond to our intuition about the relative significance of the fields. Title is weighted way higher than the body, whereas for the score combinations weights, on the other hand, are not as intuitive. Figure 2 depicts the results of the term frequency combinations technique and the score combinations approach for various title field weight values. Let us first go through the Reuters results, which is the figure 2 on the left. The suggested field weighting strategy, term frequency combinations, operates as predicted. For a weight value of 1, they retrieve the results obtained without any field weighting. Then, as the weights for the title increase, performance increases, reaching a peak around 8 and then gradually decreasing. The score combination technique is severely harmed by field combinations. As you can see, unlike the score combination scale, the term frequency combinations weighting scale is extremely intuitive. Now on to the right hand side of figure 2, where it is performed the same experiment, but on the .gov task, which nevertheless still yields the same results. The term frequency combinations approach, once again, outperforms the score combination method. The score combinations weighting scale is once more counterintuitive. To conclude, the current standard approach of weighting fields of a document using a linear combination of scores is problematic. Some of the concerns have been shown, and an alternative, as presented, would be the linear combination of term frequencies. A linear combination of term frequencies appears to overcome many of the concerns, with the added benefit of simplicity and possibly decreasing the work necessary to optimize the tuning parameters of a ranking function. So, the new technique surpassed the linear combination of scores, and the ideal field weights derived from it were considerably more intuitively understandable. However, term frequency combinations have some disadvantages. Because it is based on the bag of words model, therefore it does not capture position in the text, semantics, co-occurrences in different documents, etc. Thus, it's only useful as a lexical level feature. Up next is Harris to talk about the second paper.
Thank you, Enrique. I will now proceed to discuss the second paper's problem and proposed solution. So this paper presents a different information retrieval technique, which is called the latent semantic indexing, which is also known as LSI, which resolves some of the challenges and issues faced by the BM25. More precisely, LSI tackles both synonymy and polysemy, as well as independence of word types, which are essentially the three main problems treated in our second paper. So before diving deeper into some technical details around LSI, let me briefly state the difference between synonymy and polysemy. So in short, synonymy means that there are multiple words for just one meaning, where polysemy, on the other hand, refers to one word having multiple meanings. So LSI addresses these problems by offering a way to replace an incomplete and unreliable representation of terms with some other set of entities. And this set of entities considers latent semantics, which can be regarded as a more reliable indicand for meaning and context. But how is that exactly achieved? So this is where a mathematical technique called singular value decomposition comes into play, which is also known as SVD. And essentially, SVD decomposes the original term matrix, third document matrix into three submatrices, namely a term matrix, a document matrix, as well as a diagonal matrix consisting of eigenvalues. This decomposition allows us to perform linear algebra operations more efficiently, since we're dealing with submatrices of smaller dimensions. And also, LSI helps overcome synonymy by increasing recall, which can be considered one of the most problematic constraints of Boolean keyword queries and vector space models. In fact, synonymy is often the cause of mismatches in the vocabulary used by authors of documents as well as users of information retrieval systems. As a result, Boolean or keyword queries often return irrelevant results and miss relevant information. LSI is also used to perform automated document categorization. In fact, several past experiments mentioned in the paper reveal correlations between the way LSI and humans process and categorize text. In other words, we might state that document categorization in this is the assignment of documents to one or more predefined categories based on the similarity to the conceptual content of the categories. With this theoretical background in mind, let me now hand it over to Nia, who will briefly discuss the results obtained from the LSI applications discussed on our paper.
Thank you, Aris. So, as we just saw, LSI offers tremendous improvements compared to BM25. Not only can LSI deal with structured documents by taking into account different bodies of text, LSI also considers context. These features resolve both synonymy and polysemy issues and dramatically increase the relevancy of ranked documents. However, the actual breakthrough of LSI, which is definitely worth mentioning here, consists in the finding that instead of only relying on the keywords used in a query to detect and rank relevant documents, we can extend the level of information carried in the keywords with the feature vectors describing the characteristics of the words in question. These feature vectors can be described as a semantic representation of the words to which they are associated. In the next step, and this is where the magic lies, or where the magic happens, the feature vectors are transformed into numerical representations, which then allow us to perform linear algebraic operations on the obtained matrices. Last but not least, this numerical representation of feature vectors enables the computation of fundamental comparison quantities such as word-to-word, document-to-document, or even word-to-document comparisons. Now, before reaching the end of our presentation, let me hand over to Amir, who will express our opinions on the two papers on our behalf.
Right, thank you, Nia. So it is our opinion in general that paper one didn't really require a whole paper, as it was just a very simple adjustment to the BM25 and how the weighting vector was applied. We believe that BM25 these days is quite redundant, especially for, in industry, and other more complex methods, such as those discussed in paper two, are far more relevant to the information retrieval techniques of today. And we also believe that the effectiveness of the model displayed under paper two is highly dependent on user-defined parameters, which does provide a high level of flexibility for a model of information retrieval. We also generally acknowledge that the ability to work with text on a semantic basis is essential to modern information retrieval techniques. As a result, the use of LSI has significantly expanded in recent years as earlier challenges in scalability and performance have been overcome. LSI has proven to be a very useful solution to a number of conceptual matching problems, and the technique has shown to capture key relationship information, including causal, goal-oriented, and taxonomic information. So thank you very much. This concludes our presentation. A few of our views are displayed on there. Thank you for listening.